Hi there, this is a presentation to explain the Empirical Formula Lab and how we set it up on day 1 and day 2. This is especially helpful if you did this lab in part, whereas somebody else may have done the other part for you. So the whole goal of this lab is to discover the ratio between the moles of zinc and chlorine in zinc chloride. And the driving question then is, what is the empirical formula of zinc chloride? The picture on the left are some sample compounds that have been made in the past. On the right would be a very pure zinc chloride that was created by somebody with much better equipment than what we have. But that's okay, we can always dream. So day 1, some materials and safety, and materials that we needed. Hydrochloric acid was 3 molar. It is toxic and corrosive, so you want to be careful. You don't want to inhale it. You want to make sure you cover your eyes and rinse any exposed areas with water. Zinc isn't really harmful unless you inhale the dust, which wasn't really an issue since we were dealing with fairly large chunks. But do be aware of people carrying supplies across the classroom, which was less of an issue given our small groups. Continuing on with setup. I'm going to play this video while I continue to talk. It's Mrs. Eisenhower setting up the lab. So we'd label the beaker for the period and the lab number. When we get the mass of the empty beaker, we'd record that. Then we would place the zinc in that empty beaker and get that mass with the beaker and the zinc and record. Once that's done, then you would pour all of the hydrochloric acid, the 50 milliliters of 3 molar hydrochloric acid, into the beaker with the zinc. And then watch the reaction and record your observations. And you can see here that there's some bubbling and fizzing. And so we know that that must mean that gas is produced. This will be in the fume hood for some time, and then your beaker will be heated in order to remove all of the liquid. And then later, you would see that there's still some liquid. Keep heating. Keep heating. Hey, that looks a lot better. Beaker tongs are important because hot glass looks like cold glass. And we get a mass. We record that. But let's heat it some more because this is a hygroscopic substance that absorbs water from the air. And if you watch it, you can actually see water evaporating. So you'll take another mass. Careful now. It did lose some mass, so it was a good idea that we definitely heated it again. But because it went down, we should heat it another time just to make sure that the mass isn't changing anymore. We want to get it to where it doesn't change more than like 0.02 grams. So a further heating. There we go. That looks pretty good. So now we do the calculations. But let's take a look at the steps in case this is you having to do the lab today. So just backtracking what's happening in the fume hood. The zinc and the hydrochloric acid react to make zinc chloride and hydrogen gas. Zinc chloride, once it's formed, is actually hygroscopic, meaning it absorbs water from the atmosphere, and that's why we would need to remove the water by heating multiple times. Zinc chloride itself is a white solid. It can cause skin irritation and possible burns. If your skin is wet, you would just want to wash your part of your body with soap and water for a good 15 minutes. It can cause respiratory and digestive tract issues or burns. You wouldn't want to make yourself vomit, but we would make sure we'd get you some milk or some water. And then it's corrosive to eyes, so you'd want to clean those eyes out. So data collection. You want to record your observations, just your general observations of the product, and then drive off the heat as shown in the video on the previous slide to drive off the remaining water. When it's cool to the touch or using beaker tongs, find the mass of the beaker and the zinc chloride. And this is your first one, and then you'd record it. And then as we saw in the video, you want to heat it at least one more time, but don't burn it, okay? We don't want to get rid of anything. and then get your second mass and record. So repeat if necessary for a third time. So you want your masses to be within 0.02 grams, and look at it. If you see any liquid in there, you're definitely not finished. It needs to be dry, and then you need to get 2 back-to-back mass measurements that are within 0.02 grams of one another. So for example, if we look at these 2 data points, if the first 2 are a difference of 0.05, are we finished? The answer is no. We would need to do it again and then look at the third measurement, and you'll see that the difference is 0.01. So are we done? Yes, that sounds pretty good. Let's move to the next step. So for cleanup, we want to pour and rinse the waste into a waste beaker in the fume hood, and then wash thoroughly and take off the label, and then of course wash your hands with soapy water. So now let's get down to why we're doing this lab. How can we find the mass of the chlorine? You'll know that we measured the mass of the beaker, we measured the mass of the beaker with the zinc in it, so we should be able to get the mass of the zinc, right? Should be pretty easy. Well, then we also weighed our final product. So if we know the mass of the zinc chloride and we know the mass of the zinc, couldn't we get at the mass of the chlorine? Just subtract the mass of the zinc from the mass of the product, and boom, you would have chlorine. Now, this is a law that we didn't really discuss this year, but what this is harnessing is, actually, I take that back. We did talk about this law, the law of conservation of mass. We talked about this back in Unit 1, that the amount of matter does not change. It can just get moved around. Then what we'd want to do is use the molar masses from the periodic table and the mass data that we have to find the moles of zinc and chlorine present in the sample. And this is actually data that you're going to be submitting for other groups to access. So once we have the moles of zinc and moles of chlorine, then we're going to find the empirical formula of zinc chloride. We'll post that data on our Google form. And if we have time to do a whiteboard, these are the things that we will discuss. The mass of the zinc and the mass of the chlorine, show the calculations for the moles of each, show your calculation for the mole ratio of moles of chlorine over moles of zinc, and then finally the atomic ratio of the number of atoms of chlorine to number of atoms of zinc, and then you would write down your empirical formula and particle diagram for zinc chloride, and this will all be very helpful for your lab because you will be turning in your lab report. So in conclusion, how could we get all the same approximate value for our empirical formula, even though we started with different masses? You might think back to the ratio with which atoms combine to form compounds. Does the ratio matter? This is a law that we definitely didn't talk about this year, but it is important, the law of definite proportions, which basically states that elements combine in the same mass ratio in the same compounds. And this is basically the same idea as what we saw with the electrolysis of water, that it always combines in the same ratio no matter what, 2 hydrogens for 1 oxygen every single time. Same thing here with our zinc chloride. And then think about errors that you could explain if your values were too high compared to the rest of the class. So if you had more chlorine to zinc than other groups did or less, what can you think of that would explain that difference in your ratio? For example, if your chlorine was too high, perhaps you didn't heat it enough, and that would give you would think that you would have too much chlorine because your final product would have a greater mass than it should. And because we got chlorine's mass by subtracting the zinc out of the product's mass, you would assume that that was chlorine. But if there was still water in your sample, then you're basically getting too much of a chlorine mass. Well, what if it was too low and you didn't have enough chlorine? Then you probably heated it too much, and the zinc chloride can actually decompose and turn into a gas. We're doing a phase change essentially if you heat it too long. Then you would want to finish up your conclusion questions, and then you'll be turning that guy in. So I hope that helps, and we'll see you soon.